So the first one is a projectile motion. We have a golfer that kicks a golf ball at 30 degrees. We have golf ball. It gets kicked at a 30-degree angle. With an initial velocity in meters per second. And then you're going at resistance. So then the projectile motion, you can just kind of imagine it goes up and then comes back down. It's asking you max height. Remember that at the top here, we do 0. And because it's symmetrical, coming down here, time to go forward in the air, how far it turns. Intensity. I'm gonna write arithmetic. So which one do you guys think we should start with first? So it says ignore air resistance. So I think should start with the one in the middle. Middle? Okay. That makes sense because we have our V final here. Yeah. Right. We have our V initial here. And then we have our acceleration, which we know is gravity. Yeah. So then we're just solving for T. Do I have to do anything here before I use that equation? Think about what direction. Oh, yeah, so it's on the x-axis. So since it's going forward, it's always going to be 0. It would be on the y-axis, right? So we need to find a component. So wouldn't it be the other equation because it's distance? The 1/2 AT squared. You mean like the other? The max height? Yes. Yeah. But you're still gonna have the same issue. Here, if you do this right away, you don't have, you're solving for x final or y final, sorry. Which one do you want? You have V naught, you have acceleration along which axis? The y? Yes. You have acceleration on the y-axis. You don't have time and you don't have y, so you can't solve for both of them in one equation. So that's why we're going to use the conversion solve for time first. But what I was trying to get at is you have to find the x and y component. So you're going to need to solve for v not y because you have acceleration only on the when it's coming down. Yeah. Which is negative 1.8. Yeah. Okay. So then what are we going to use to find the components? Trig function. Okay. Do you know which one? Or can you guide me through how you're going to figure it out? Is there perhaps a mnemonic I should write? I use cheap Sokoto. Yeah. I use that too. Right? Where this is the opposite, this one's adjacent, and this one's my hypotenuse. Yes. So then for the y, we're probably going to use which one? Sine, cosine, and tangent. Will it be fine? Yeah, it's gonna be fine. So this one's gonna be fine. Maybe not fine. Right? Because we have fine, theta is equal to opposite, which is that be not y, over hypotenuse, be not. Just multiply that over. Then you get b not sine theta. Cool. So then we can plug that into there. We have b and b not negative g. So then we have 0 meters per second. Is equal to 16 meters per second. Sine 33 minus gravity, which is 9.8 meters per second squared. Right? And because this one's pretty simple, I feel comfortable just plugging them directly in. You could, of course, like solve for the variable by itself. So, y or g equal to t, and then plug it in there. But yeah. Over. You have better mark. This is the only one I found. Here you go, Dee. Thank you. Right. Remember that it's like meters per second, meters per square, that's the result of seconds. So it's like meters per second or meters per second squared. There's two ways of doing this. One is doing the inverse of one, so you do meters over seconds times seconds squared over meters, then cancel them out like that. I just did this like breath thing, meters second squared, cancel them out that way. But that's just double checking that your units make sense. And that should result in. I'm not good enough to do it off the top. To 0.816 seconds. Cool. And then from there, now we can use this equation because now we have our t. Then we do y to y naught, b naught t, negative g squared. This is already isolated for this we want to solve for. So I feel comfortable just plugging everything in. Y to y naught. We can define it as 0. And then the maximum is 0 because before an object falls down, it has a resting point, right? Yes. So that's for velocity only? Or like it can't be for acceleration. Well, no, because acceleration is describing the change of velocity. If your velocity is 0, then your acceleration is 0, your velocity is not going to change at all. I'm actually going to stop recording. So this one, yeah. So that's our diagram. Remember that we have u naught, we have the y and x components, we have our kinematics equations. And we're gonna use the this one here. So that we can solve for t, and then from there we can plug t into this one. What we did here. Yeah. So plug it in, these are your values, solve for t, x with t. Plug it into your y equation. Solve for y. Remember that it takes the same amount of time to get to the top as it does to the bottom. So then your total time is 2 times the time you found here, which is the time at the top. And then this is just the answers for the problem. This is the little diagram showing the velocity vectors and acceleration vectors at different points. Main thing is acceleration is constant throughout. Velocity is symmetrical on the ends, but just in a positive direction versus a negative direction. And the x velocity is constant. We have an acceleration. And then we solve for x as well. This is just for the which one we use cosine sine. And then we just decided to use the definition of velocity because we don't have any acceleration in the x direction anyway. We isolated them out. We defined x naught as 0, that goes away. Remember, we're using v naught of x. Okay. So we have a given acceleration of 9 meters per second squared. Second cube times t. So this is going to be a non-constant velocity, which means we're going to integral it to get to velocity, or do the derivative won't take you anywhere. So you're going to take the integral to get velocity and displacement. All right. So we were given an acceleration that is a function of time. And so thus we knew to integrate because it's a function of time. And if you're going to go down from a, b to x, you're integrating. If you're going up from x to b to a, you're deriving. From the v, we integrated again to get x. And then we just plugged in the times for those values. And then that over there in the green is just us double checking that the units make sense.